When we last left it, I was just milling along here, and I then said I'd go off and do some really boring stuff, which I did off camera, which is the 2 pivot points and the rest bar. So this will sit at the front, and all it was a really simple, some would say boring, turning job. So I decided I'd do it off camera, and it was only when I finished it that I really thought, actually this would have probably made quite an interesting bit of video. Let's give that a wipe and I'll explain why. Good old blue roll. It has, as you can hopefully see on here, 2 lines, and they are the ends, and they come out and go in, and they're nice and tight. They rotate with a bit of effort, they don't wobble, and they're a really nice fit. So basically it was done in the lathe in the collet chunk, so I can hold this in the 1/2 inch collet, no problem at all, and I know I'm central and everything else, and all it is a bit of turning, and I've decided to take these at 5/16 because that gives quite a nice solid outside edge. That's not too thin, and that's a nice thick piece of steel, so that will hold quite neatly. So I thought, great, 5/16 it is, and I've got a 5/16 reamer. That makes life nice and easy. So all I've got to do is drill it, ream it, job done. So turning down to 5/16, no problem at all. Nice easy bit of work. Knock the edges off there with the chamfer bit, and then it came to drill and ream the hole, and this is where my brain went a little bit south, because I have got a 5/16 reamer, but what I forgot, well, actually not that I forgot, I didn't even consider it, although I know this, is that a hand reamer has a slight taper on the front edge. So I drilled it out at 7.6 millimeters, and 5/16 is approximately 7.9, so that gave me a nice amount to take out. I then dropped the speed down to 76 RPM, put the reamer in, took the reamer out, put this in, and it went in about that far. Okay, and then it suddenly remembered the taper on the front of a hand reamer. But luckily I did have an option. I'll go and get it, and this is one of a set that I picked up many moons ago, but very rarely gets used, certainly in this side, and it's a D-bit, and I bought a set of those, and I have a 5/16 D-bit, and because I've got a 5/16 reamed hole, that D-bit would sit straight down into that, and then it just took out the bottom part, also made the bottom of the hole square-ish, and then having run that in and out a couple of times, I have a nice tight fit, no shake and wobble. But as I said, it ended up being rather more operations on the lathe than I'd really thought about to start with. No. What's interesting about drilling and reaming? Absolutely nothing. What's interesting about drilling and reaming a blind hole? Quite a lot more. So apologies for that. But the next part of this is going to be setting this these up in the V's, clamping the two plates together, then drilling through 5 holes in that one, 3 in this one, and this will have 3 holes from the top and 2 from the bottom. As you can see, well, you probably can't see there, there are 3 holes that go through. So flip it over, drill through into there. That will screw up against the inside face of this, which is the top. This will be drilled in 3 places and fit against the top. And then with the bottom on, I will then drill and tap 1/2 inch into there. So the outer ones will be held in the bottom. I did a little bit earlier and forgot to turn the camera on, so apologies for that. I'm now drilling through, and I have just drilled through into the bar, and this is the front, so this is actually the piece that will pivot, and I've drilled into the outside edges 1/2 inch in, drilled through 3.2 mil, drilled through the next piece at 4.1, and I've then countersunk here, and I'm about to countersink the other side. I'm going to do it earlier rather than later, simply because I need to tap in, and that depth is getting very close to the maximum I can tap. So I'm going to put the countersink bit in a moment. I'll get this one out. And I've got 6 more holes to drill, but this time from the other side. The pilot holes are already drilled. I just need to line the drill up with those, drill into the bars, and then tap. This is slightly cheating because obviously, well, not obviously, but one of the reasons for drilling through the top at clearance size is not only that the screws got to go in there, but it also means that as I've drilled them at the same settings, the clearance size hole actually acts as a guide for the tap, which to me seems vaguely sensible. So that's the, and I haven't used a taper tap in here, I've used a number 2, and then just following it up with a mildly modified plug tap. And when I say mildly modified, all I've done is I've taken the very small lead in at the front and the slight tip on it, I've ground that off so it's flat bottomed, and that means it will go in as far as it will go. Yeah, that's it. That's down as far as it will go. Hopefully that means I'm in far enough that my 20mm screw will go down all the way. Yeah, I can't see a problem with that. Okay, so that bit is now done. What I need to do now is to flip it over and do the same the other side. Once I get, and I know the front's not going to move, so once I get that flipped over, I can then drill into the centre of this from the top, do exactly the same there, and then that will hold that in place for good. So I just need to make sure that the sides are aligned, which they are. So I'll unclamp it, flip it over, do the same the other side at that end, and then come along and do the 3 wider spaced screws at this end. And the way I'm doing it is that this will then sit on the 2 V's, that's its home position, and then I'll mill the inside of the base so that that will have enough gap underneath to take my smallest gauge block, and then I can push up from there. Right, let's get this off. Don't suppose you want to watch that, do you? No. So we're coming on to the next hole. I've just lined the workpiece up so I can get that drill straight down through the hole. So I know that's now lined up. It's the same drill, 3.2mm. What I've done here is I've taken this down as far as I can. It's now touching the top of the roller. So, and I've adjusted the vertical height of the table so that I've got 3/8 clearance here and to the stop. So I know now that I will drill in 3/8, and this is 1/2 inch, so that will give me clearance at the bottom. Okay, that's that hole drilled. Okay, now this one again, slightly different. I want to drop this table down a bit because again, I only want that is going to be 15mm. So I want 15mm there. Take that up a little bit. 15mm. Right, that will take me down into the void underneath here. I should feel that the drill bit go through anyway, but there's no harm in playing a little bit safe, because I don't want to drill straight into the 1/2 inch bar. Yeah, just feel that go through there now. Lovely, so I'm now drilled into the void. So I've got a clearance hole through. That's more than enough. That's it. That's got the full width of the countersink there now, but because of what I'm doing, I'm not going to use anything like that with a 4mm. Countersunk head screw, so it's going to recess itself quite a long way down. Okay, that's the second tap through, and it's down to the bottom of the hole. That and that. I'll now take this off of there, move it over to the other side, and drill this hole. What I've got to hint here now is the upper plate face down. I've marked off the corners where the hinges fit that are mounted to the bottom plate, and I've now recessed those and cut the shoulders in so that those pivoting sections will be clear of this. I'm now just cutting along. I'm using an 8mm 3-flute cutter, and I'm just cutting down, and I'm going to cut the end off. I'm running this at 1600 RPM. I'm using coolant, but it's all manual feeds on this machine doing this. And I'm taking a 30 thou cut. So dovetail cutter is the next thing to go through on this. Okay, it's nice and tight. Take these two panels off. I think 500 RPM seems quite reasonable for this size cutter, especially as it's high speed steel and not carbide. And I think, looking at the debris I'm getting on the inside of the cover here, that I'm going to need to do a belt change on this soon. Get it the right way up. Right, let's see where we are. That off. Let's have a quick look at this side. Yeah. I'll show you that later, but what I've done now is I've angled this, so I've only got about a 2mm land at the top all the way along, and then it goes out. That will give me a bit more clearance now, so that when I try pivoting it, it should pivot. I'm also going to mill down a piece the same width as this, or slightly, very, very slightly wider on the base, so that when I lift this up, that will then go into the recess. That'll give me even more clearance. Well, off camera, I've rough milled out a section at this end, and I'm using an 18mm 3-flute slot cutter. So it's centre cutting, so I can plunge cut into the work. I'm going to take that out now and replace it with a carbide cutter. But this one is not centre cutting, it's an inserted bit cutter. This is the one bit I don't like. Because there are precision bearings in there which I've just hit with a hammer basically. So what I'm going to do now, quite simply, I'll take this up. Because this is a different cutter, its height on the Z-axis is going to be in a different place. So I'm going to start that up. And just get it to touch off. Okay, so let's zero that out. As you may notice, I've cut a sort of a T shape. I've gone down to 6 thou off of full depth in the cross slot section of the slot, and I'm 16 thou out on that piece, so I can come across here, go down, but I don't want to go with full depth, so I'm going to, what's that, 30 thou. Let's go to 25 thou depth of cut. I think I'll take the speed up a little bit on that because it's a carbide tips, so I'll just change the speed. Well, that's the first of the cuts, so what I'll do now is I'll just carry on off camera until I get down, because it's going to be a number of cuts to get to 166 thou, so I'll come back at the end. Well, I'm just about to take the last cut round here. I'm only putting the recess in by about 50 thou, and I'm using the 63mm 4 cutter carbide face cutter I bought not that long ago, and so I'm not going down far. I just want to put a bit of relief in there so that I don't get little bits of swarf lifting it up off the bed. I'm running it at 970 RPM, which with a carbide isn't too bad. Biggest problem is I can't have my cup of tea around here because the swarf is flying off everywhere, which is why I've got the bump cap on, as I seem to be lacking in natural protection on the top of my head to hot pieces of swarf. Right, let's do the last few bits on this. Down, see if this did do a nasty little job on me of loosening off on the bottom of this cutter. No, that's nice and tight. Okay. minus 51.7 it shows up on there. So before I go any further, let's grab some cutting paste. And just spread a bit of cutting paste over here. With the heat in this workpiece at the moment, it's almost like cutting fluid as soon as you put the brush on. I've set this up on zero across there, 0, 0 in that corner, and a dead stop at this end. And then this side I take out to 2.20 inches. Minus 48. So now let's get rid of some of this swarf. It's all over the floor at the moment, so that's going to have to come off. Well, this is where it all gets a little bit on the nervous side. I'm accompanied with copious amounts of blue roll and not a little finger crossing. So I've blown it out with air, I've rubbed it, taken it down with some blue roll to get as much out of here as possible. And I'm going to put a little bit, a very little bit of copper slip or as it's now called, anti-seize compound. I'm going to put a drop of that on there, and then we'll see if this goes back together, which it seems to want to do. Well, that's good news. Well, that's gone in there okay. Now I need to put that up on end like that. I'll put that up there. The next little bit is to find that, give that a quick wipe down. Again, a little bit of anti-seize on there, a screw, hopefully this will line up. Of course, this is the one that's got the very I'll find out in a minute whether I've actually managed to get the hole lined up. Yeah. Oh, you lucky so-and-so. gone straight in. Couldn't do that again if I tried. Right, that's in there. Let's tweak that up a little bit. And tweak that one up a little bit. Then if I move that round a shade, I can get down here and just wipe that clear. Make sure that my bed is as clean as I can possibly make it. Then if I do that, and I've got it the wrong way around of course, and do that, that goes over there like so. That goes over there like so. A little bit of wriggle room, but I can then clock that in, and that will go up probably quite a long way. Let's take that down. Actually what I'll do, let's zoom out a little bit and give you a bit more of an idea of exactly what I've got here. Well, that's as far as it's going to go before it hits anything. But that's going to be somewhere around 75-80 degrees, so I don't think I'm going to need to go any higher than that. If I can, I'll need to just make a few more adjustments at this end. But that now will sit down and will, once I get the right length bolt in there, drop straight down onto that piece. So let's find the right length nut, and then we can go from there. As per usual, I can't really wait to actually see if it sort of does the job, and it does. So I put a stack of gauge blocks at the back here, drop that onto them, and I'm sitting at, according to the Wixie gauge, 36.8 degrees, which is right in the ballpark. It should be 36.89, but this only reads in 0.1 of a degree, so that's about as close as I'm going to get to that. But if I can get to within 0.1 of a degree, I'm going to be happy. It's a lot better than the lash up I had last time, where this was half on an angle plate and half off an angle plate and clamped against the block of alley and everything else. So it's not quite done yet. I want to cut a slot in there and put a rounded slot there across, so that I can put a screw in and screw down against something, so I can hold that back down against both the screw and also these. So I'll use these for setting up, and then I'll put a screw in there, a long stud down to a base and up through the hole, through a hole and into a slot, so I can tighten top and bottom. And that should allow me then to get the gauge blocks in, get it set up to angle, and then clamp it so it doesn't move. If I can do that, I will be a happy bunny. I'll also try and work out some form of bracing on the side to hold it at the side as well. Use a piece of steel, but I'll try and have to work out some sort of design for that doesn't get in the way of everything. But yeah, that's actually working rather better than I anticipated. All we've got to do now is just get it finished off. And what I've done here is I've put two 12mm threaded holes into the top plate, two 12mm bolts, bolt the thing straight down. Obviously on this, because of the slot at the back one needs to be in first. Push that up and then screw that one down and then tighten the back down. But that should make what I'm doing rather better, and there's absolutely no movement in that at all. So that should improve my ability to actually cut some bevel gears with the hope that they will then work.